Image formation. Consider a curved surface separating two media with the refractive indices n1 and n2. A point object is placed on the principal axis at point O. The ray which travels along the principal axis passes through the pole and it is undeviated as the angle of incidence is 0 degrees. So consider a second ray that meets a point A on the curved surface and makes an angle of alpha with the principal axis. Here theta 1 is the angle of incidence. The ray gets refracted and meets the principal axis at capital I, and theta 2 is the angle of refraction, and I is the image where the point on the principal axis. The two refracted rays meet at I, capital I, and the image is formed there. Gamma is the angle made by the refracted ray with the principal axis. Beta is the angle made by between the normal and principal axis. Any line drawn from the center of curvature on a point on the curved surface becomes the normal. So this is beta is the angle between the normal and the principal axis. And capital N is the normal drawn between the principal axis and the point where it is meeting on the curved surface. P is the pole, C is the center of curvature. And PO is the object distance denoted by U. PI is the image distance denoted by small v. PC is the radius of curvature denoted by capital R. N1, N2 are the refractive indices of two medias. Now we have to establish a relationship between these quantities. In this triangle ACO, theta 1 is the exterior angle. According to the properties of triangle, exterior angle is equal to sum of the two interior angles in the triangle. According to that, theta 1 is equal to alpha plus beta. Next, considering ACI. Here theta 2 and gamma are the interior angles, beta is the exterior angle. So beta is equal to theta 2 plus gamma. Beta minus gamma is equal to theta 2. And according to Snell's law, n1 sin theta 1 is equal to n2 sin theta 2. Substituting theta 1 value from the above and theta 2 value from the above, now we'll get an expression like this. N1 sin of alpha plus beta is equal to N2 sin of beta minus gamma. According to this, the angles which are passing very parallel to the principal axis. If the rays are passing parallel to the principal axis, then the angle made between the refracted rays and the principal axis becomes small. So that is called paraxial. Those rays are called as paraxial rays, and the approximation taken as paraxial approximation, and the angle made between these refracted rays and the principal axis will be very small. So we can write sin alpha plus beta is equal to alpha plus beta. Sin of beta minus gamma we can write as beta minus gamma. Substituting these two values in the above expression, we will get the second expression like this. N1 alpha plus N1 beta is equal to N2 beta minus N2 gamma. This is the second equation. As the rays are passing parallel to the principal axis, according to the paraxial approximation, here tan alpha becomes alpha, tan beta becomes beta, tan gamma becomes gamma. According to from these triangles, if you take A and O, from this tan alpha is equal to opposite side by adjacent side. AN is the opposite side, NO is the adjacent side. In the same manner, tan beta is equal to an by nc. An is the opposite side, nc is the an is the opposite side, nc is the adjacent side. Next, tan gamma. Now here we consider ACI. Then tan gamma is equal to an by ni. an by ni. An is the opposite side, ni is the adjacent side. So substituting, so we have alpha value, beta, gamma values. Substituting these three values in the above equation 2, then we will get like this. Substituting those equations into, then we will get n1 an by no. This is alpha, an by nc. This is beta, an by nc. This is beta, an by ni. This is gamma. This expression we will take it as 3. Here, as the rays move very close to the principal axis, here as the rays close very to the principal axis, then the point capital N coincides with the pole. Here the N normal coincides with the pole. So in that case, we will take Pi, Ni, Nc and No. We can consider as